Okay, hello everybody. So today we're going to continue our discussion in Chapter 2, Section 3. In the last video, you should have learned a little bit about how we use notation. We use set notation to describe intervals over which functions might be increasing or decreasing. We also use that set notation or interval notation to list any domains and ranges that we might have. So what we're going to do today is we're going to continue talking about some other aspects of functions. And the first thing that we're going to discuss is what a relative minima or a relative maxima is on a function. And it's a pretty simple concept, really, that it indicates a point where the surrounding points are less than or greater than, depending on whether you're talking about a minimum or a maximum. So in the case of a maximum, you can see here we have a relative maximum, and it happens at the top of these graphs, right there and right there, for instance. And so you can see that the surrounding points are less than the graph that you see. In a similar fashion, the minimum point, the relative minima, is happening down here, and it's at the very bottom of the graph, and it's indicating that the surrounding points from that are below the other surrounding points. So sorry about that. My stylus was running out of battery, so I had to get it plugged in. So you can see the relative maxima, relative minima. If you think of the maxima, they're like peaks at the top of a mountain, and the minima are going to be happening at the very bottom of the valley. Now, the thing to keep in mind is they're not actually maximum values, because this graph technically would go down like this forever, so that it wouldn't have a minimum. This graph would also go up forever, and it would not technically have a maximum. But we have these things called relative minima and relative maxima. They are really easy to find on your graphing calculator. All you have to do is go into the graphing calculator screen. Once you've graphed, and I'll pull it up here real quick to show you how to find a minima and a maxima. But in your graphing calculator, once you have the equation graphed, like this, for instance, you can simply hit second calculate, and you can see that it asks you if it would like to find the minimum or the maximum. If you choose, I chose minimum, you would actually, I want to choose maximum because it'd be easier on this particular graph. And then it asks you for a left bound. So you want to make sure the cursor's to the left of the maximum. Then it asks you for the right bound, and then you hit enter again. And you can see that there's these two vertical lines, and what it's doing is it's focusing the calculator in to just between the two lines. And then it'll ask you to guess, which means just put the cursor where you think the maximum is, which I think it's right there. And when you hit enter, it will tell you exactly what that ordered pair is. So it's pretty easy on the graphing calculator. And this is just a description, a mathematical definition of what a minima and maximum are. You guys can read that. It's pretty straightforward. So it says we will study a technique for finding the exact point which a second degree polynomial function has a relative minimum or a relative maximum. So let's talk about that for a second. A second degree polynomial, which would be an x squared, and we know the graphs of x squareds are parabolas like this. So where are the minimums going to occur? It's going to be right there, and the maximum is going to be right there, otherwise known as the vertex. So you guys actually already know how to find the vertex using two different ways. Hopefully you remember both. But the first way that you actually learned last year in Algebra 2 was negative b over 2a, which gives you the x value. And once you have the x value, you can plug that in and get the y value. The other way is to complete the square, which is what we learned this year. And you can get the vertex from that as well. Now, another aspect of graphs that we should talk about is something called the average rate of change. And so what the average rate of change tells us is how steep a graph averages over a certain distance over the graph. So if you recall that when we have a linear equation means that the graph is a straight line. And what's special about a straight line compared to all other graphs is a straight line has a constant rate of change, meaning it doesn't matter whether you go from here to here and figure out the slope, or you go from there to there, or you could go from this very bottom point to this top point. The slope is going to be the same throughout that entire graph. It has an average rate, a constant rate of change. So what we have when we get into higher order polynomials, x squareds, x thirds, x the fourth, is we start to get these curvy graphs that have different rates of change depending where you are at the graph. So for here, it would be a little less steep. As you go up here, it would be a little bit steeper, and then it starts to cap back off. And by the time we get to the very top of this graph, we would be perfectly horizontal, if I could draw that. So the rate of change is not constant anywhere on that graph. And so we get something called the average rate of change. Now, the average rate of change to find is really easy. All you do is you find your two ordered pairs on the graph wherever you want, and you simply find the slope between those. If you look, remember, the slope is the change in y over the change in x. Now, how do you know how far apart two numbers are? Well, you subtract. So when I do f of x sub 2 minus f of x sub 1, that is just like having y2 minus y1. And then I do the same thing with the x values. I do x2 minus x1. So the average rate of change is just a fancy way of saying find the slope between the 2 points. And one other thing, it says that the line through the 2 points is called the secant line. And so they are referring to this line right here that's in gray. That would be called a secant line. And you can see that it is labeled right there as such. So this particular problem would like us to find the average rate of change, and it gives us two different problems in one to do. So you can see they gave us the function f of x equals x cubed minus 3x, and they said find the average rate of change when x1 is negative 2 and x2 is negative 1. So remember, in order to find the average rate of change, it's the exact same thing as finding slope. In order to find slope, you have to have ordered pairs. So what we need to do is we actually need to find the y values that go along with these. Okay, and the way that we would do that is we could do it either by plugging these x values into the function for x right there and there and getting our answer, or we could look at the ordered pairs and see if they gave you the graph. So by plugging negative 2 in right here, if I do f of negative 2, I get negative 2 cubed minus 3 times negative 2. So negative 2 cubed is actually negative 8, and then plus 6, which gives me negative 2. So when I plug in negative 2, I get negative 2 back out. So there's my first ordered pair, and you can see it's right there. The second ordered pair, I would need to plug negative 1 in, and that's negative 1 cubed minus 3 times negative 1. So that would be negative 1 plus 3, which is positive 2. So the answer for this one would be 2. You can see the ordered pairs right there. So negative 1, 2. Now that I have both my ordered pairs, I can simply do the y2 minus y1. So y2 minus y1 over x2 minus x1. And that's going to be 3 over 1, which is 3. So the average rate of change for here, for this first part, for this part right there, is we're going up 3 for every 1 over. And that's what the average rate of change is. For the second one, I'm not going to plug the numbers in because you can see we have the 2 ordered pairs right there that we need to find. It's just a matter of doing the y2 minus y1 again. So when I do that to find the slope, the y2 is going to be negative 2 minus y1, which is 0, over x2, which is 1. This is x2, y2, and this is x1, y1 for a second problem. And then we're going to have 1 minus 0. So it's going to be negative 2 over 1, which is negative 2. And that's going to be your average rate of change for the second one. So that's the slope of that line right there. Okay, that's what I have for you today. As always, if you have any questions, feel free to email me. Have a good day.